something like that. And if you want to say, what is the derivative when x equals 3? You, of course, could write it like this. But you can also write it, sometimes they write it like this. Okay, just another notation. Just means the derivative when x equals 3. Or you could write it like this. Okay, it just means when x equals 3, what is the derivative? Okay, that's just, I didn't mention that before, but I think the book uses that notation at times. So I realized I forgot to mention that. Okay? Alright, now this is the important topic. So suppose we have a function that looks like that. Okay? And suppose this represents profit. Well, that doesn't make sense. We don't usually talk about profit when we're doing negative things. So let me redraw that. Suppose it looks like this. In fact, let me just make it simple right now. And suppose this represents profit. Okay? Now, no, I'll change it. Like that. Okay, now let's say this is 1,000. This is 600. This is 300. This is 1,000,000. This is 75,000. And this is the same. Okay? Okay, everyone understand? Okay, so we want to use these words: extrema, maximum, minimum, relative, and also another word, stationary. And I think that's all for now. Okay, we need to identify these words. So what do you think extrema, what word does that sound like? What word that you know in English does that sound like? Extrema. It's not a normal word. I think it's only for math. But it sounds like something else that you know in English. What is it? What word? Extreme, right? It sounds like extreme. What does extreme mean? Well, I think everybody knows what that means, even though you're not necessarily native English speakers, but I think you all know what extreme means. Extreme means like far, or unbalanced, or something, right? So, and what about maximum? Maximum means biggest, and minimum means least. And those are the ones I want to talk about first. So, so let's call this function p, or p of x. Okay? So, we say this function has a maximum when x is 300. Has a maximum. Now, by maximum we mean we're talking about the height of the function. So where is the function highest is what I mean. Now, I'm sorry, I need to say, I would say the function has a maximum and then I have to say within the range. So I mean, I'm not talking about if x within the range of 0 to 1,000. So I'm not talking about over here, because here it goes up beyond, gets higher. So I'm just limiting my view to between here and here. So within that range of x, we say it has a maximum when at 300. What does that mean? It means at x equals 300, it reaches its highest point. Now it also reaches that same height when x is 1,000, right? That's the way I tried to draw it. So then we could say it also has a maximum at 1,000. Okay? Of course, as I said, I'm only restricting my view. I am restricting my view between just 0 and 1,000. Okay? So we say that it has a maximum at 300 and a maximum at 1,000. And then what would you say about the word minimum? Okay, what this minimum, sorry. Let me draw it like this, just, I don't know why, but the book did it like this, so I'll do it the same way. Okay, now what? What would you say about minimum? Let me say it again. What do we say about maximum? The function has a maximum at 300 and at 1,000, right? And what is that maximum? That means what's the height then? When x is 300, what's the height? 1,000,000. And when x is 1,000, what's the height? 1,000,000. So the maximum value is 1,000,000 and 1,000,000 at 300 and 1,000. Now, give me the statements about minimum.
X equals to 600.
When x equals 600,
And 0 as well.
yeah, and finish the sentence.
It reaches the minimum point.
It reaches the minimum point. Okay, that's good. It reaches the minimum point, or it has a minimum there. We usually say it has a minimum there. So it has a minimum at 600, and it has a minimum at 0. Right? And let's say again for the maximum, how do you say it? The function has use the same language that I used.
When x equals to 300 and 1,000 as well. So it is the maximum point.
Now, I don't want to use the word reach. You can use the word reach, but I don't want to use it like right now. I just want you to say it the way I said it. So say it again. Say it the way I said it. I'm the teacher here. Now, it's better if you, I don't know, I think there's a reason to say it that way. Somehow it fits in your brain better.
When x equals to 300 and 1,000 is the maximum.
Okay. Okay. I still want to say it this way. I want you to say it this way. The function has a minimum at 300 and 0. So say that. Everybody. 1, 2, 3. At where? 600 and 0. And now say the other one without me telling you exactly how to say it. Say the other one for the maximum. At where? The function has a maximum at 300 and 1,000. Now a better way would be to say it. The function has a maximum at x equals 300, but I wanted you to say has a. I don't know why. That's the way they say it. So the function has a maximum at 300 and at 1,000. Okay? And then we say it has a maximum here, and here we say the maximum is That means the height, what the height is. The maximum is 1 million. Okay, that's the language. A lot of times if you don't say it the same way, then when I say it, it's not registering in your brain the right way. Okay, so I try to do that. Okay, so, alright, so does everyone get it? So the function has a maximum at 300, and the value is 1 million there. It also has a maximum at 1,000, the value happens to be, the value is also 1 million. Okay, and so on. Okay, everybody get that? Okay, now, we want to, however, distinguish between the point x equals 300 and x equals 1,000. Or, maybe I'll even do this. I'll change my focus to make it 1,200 and make this, let's say, this. So if I change the focus all the way out to here, now where does it have a maximum? Only at 1,200, right? The maximum value is occurs at when x equals 1,200, and the maximum is 1,300,000, right? Okay? Everyone agree with that? Now, however, 300 is still a point of interest, I think. Or you're not interested in 300 at all. Well, I think if you were involved in running a business, you would also be interested in the point 300. Why? It's a kind of a maximum, right? We're talking about profit here, and it's a kind of a maximum, right? So it says like if you produce about 300 items, you're going to kind of maximize your profit at least within this range here, right? So that is interesting to a business owner, right? Or, yeah. So this point is still of interest, even though it's not the maximum, right? So we need a word for it then. So what word are we going to use? This one. We're going to call it a relative maximum, as opposed to, I forgot one more word. As opposed to that, an absolute maximum. So we say this function, if we're only looking between 0 and 1,200, has an absolute maximum at 1,200. Okay? But we also say that it has a relative maximum at 300. Now, it's a pretty good trick to say what you mean by a relative maximum, to try and say in words the definition of a relative maximum. If you can do it, I'll be impressed. If you can give me the definition of what we mean by a relative maximum. Everybody agrees that it's a relative maximum. You seem to know what I'm talking about. So we're communicating with a certain idea between each other. But can you put that idea into words? What does relative maximum mean? Can you put it into words? That's the interesting thing about math, is that you have to put everything into very, very clear definitions, and it's not easy. Even though you know what it is, making it very clear isn't easy. Can anybody do it? Anyone want to take a try? What do we mean by the fact that 300 is a relative maximum? Isn't that funny that it's so hard to do something that you know the meaning of?
Is it like a function has a maximum within a domain? Or
Maybe. What do you mean by that, within the domain?
like be- it's not at the beginning or the end of the domain. Instead of at the beginning, at the edge, they're within the domain.
That sounds like a good start. That's like a good start. But how come this isn't a relative maximum?
The function has an extrema.
But what do you mean by extrema?
I don't know, I just guessed.
Highest value. Extrema means you mean maximum, but so okay, that's good. Okay, so here's a good way to start to think about it, isn't it? And that is, why do we say it has one here but not here? So like you start to hammer away at the problem by, maybe shifting around or something like that. So why is it here but not here?
Because it doesn't have any number.
Huh? What?
Doesn't have any number, so we can say
No. Let's say here, suppose this is 500. Why is that not a relative maximum? Or should we call it a relative maximum? I don't think anybody wants to call it a relative maximum, but why not? Why do you want to call this one a relative maximum but not this one?
It's the vertex of
That's okay, but what do you mean by vertex? You're going to come right back to the same thing. What do you mean by vertex? You mean highest point. Okay, but why is this not a vertex then? Well, why not? What do you mean it's not a highest point? That's what we're trying to say. Why is it not a highest point?
because at that point the vertex is not like
It's not what?
it's not highest.
Higher than what?
The maximum profit
Higher than what?
than when it is 300.
Oh, okay. Then how about here? At 1100. Is that a relative maximum?
I think 380 the relative maximum because like the two nearest like value is smaller.
That's
than
it.
that one.
That's it. It's that the two, okay, she said basically the right idea, that the two nearest places are smaller. Is that true here? No, the two nearest places are, one is smaller and one is bigger. Okay, now we get a little trouble though, because what do you mean by the two nearest places? What are the two nearest places to 300? That gets a little tricky, right? There is no two nearest places, right? Right? Because you can always get closer on each side, right? But that's the basic idea. The two nearest places are less than this value. Okay? Now how are we going to say that a little more precisely? No, we don't use limit. We say that there's an interval that you can draw around this value where what? All the heights between here and here in this interval are what? Are less than the height at this place. Right? Right? So there exists an interval. It doesn't mean every interval, it's not true for every interval. Because if I take this interval, it's not true. Right? In that interval, there's a higher value than there is at 300, right? But we can draw some interval where it's true. Now, can you do it here though? At 1100, is there an interval you can draw around there so that at 1100 it's highest within that interval? No, there's no interval you can draw around there, right? It doesn't matter how small you make it, always within the interval you're going to have points that are higher than at 1100, right? That's the idea. That's right. So, and there's the one technical thing. It has to be. We have to use the open interval, not closed interval. If you think about it carefully, you'll see. If we think about it carefully, we would see that. But it has to be an open interval. You have to use the concept of open interval. So, as you know, this kind of interval as opposed to this kind of interval. But it doesn't matter. You don't have to worry about that. But anyway, yeah, that's the idea. That you can make an interval around here so that every point in that interval, the height above, the height of the function there is less than the height at 300. Now, it doesn't mean that every interval around here that's true, but there is some interval around there for which it's true. That's a definition of relative maximum. Okay? Now, we don't have much time. I need to also define what we mean by stationary point. Okay, this is kind of the key word. So what does stationary mean to you in English? Now, there are two words, stationary. You can spell it with an E and an R. They're different words. Stationary with an E is like paper and pencils. Paper and pencils. That's not what I mean. It's stationary with an A. And what does that mean? Stationary means not moving. Right? So, we say that the function is